Next, let's talk about unit testing. In a sentence, pytest is a simple framework for unit testing your Python code. It's comparable to JUnit for Java applications. It is both a Python module that can be imported and also a binary that can be invoked from the shell. Keep it simple. For example, each method you define in a class should have a corresponding unit test with a number of test cases being checked. The primary goal is to build good test coverage and catch simple problems. Pytest isn't the only solution for Python unit testing. There is another package called unit test, which feels a lot more like Java than Python, to be honest. We won't go through it in the demo, but I'll include unit test examples in the course files so you can compare and contrast the two approaches. I recommend you explore these solutions and select the one most suitable for your project. Let's explore unit testing for our CRM app by combining the TDD process with the pytest tool. Suppose we want to add a method to our database class that returns true if clients owe GlobalMantics money and false otherwise. All we have to do is check if the balance is greater than 0. Right now, we have a method stub, but no actual implementation. Because the owes money method does nothing at all, we expect any tests run against it to fail. Let's examine the tests for this method, assuming it already works, even though clearly it doesn't. I've written them in the testunit.py file. I'm importing the pytest and database modules here since we need access to our model data as well as test features. This first function is a pytest fixture, meaning that it automatically runs before each test. In short, we want to initialize our database by reading from the db.json file so we don't have to manually do it in every test function. We can access this data using db-mock, which is automatically passed into our test cases. The first test case targets the database balance method, which will return a USD formatted string in response to an account ID input. Given our JSON database, if we pass in account 100, we should see 40 USD. I'm just enumerating the expected outputs for all the other accounts. If any of these assert statements evaluate to false, either our balance method has a bug or our data is incorrect. It's important to perform negative testing too, like passing in a bogus account ID and ensuring none is returned. This method of checking outputs against static inputs is sometimes called stubbing. The second test case targets the new owes money method. Given that account 100 carries a balance of $40 and the other accounts have 0 or negative balances, only account 100 owes GlobalMantics money. Don't forget negative testing using bogus accounts. Let's run the tests using pytest-verbose and see what happens. Pytest discovered 2 test items. The tests for the balance method passed, but the owes money tests failed. This is the expected result and the whole point of test-driven development. Given that the owes money method didn't return anything, asserting none evaluates to false. Behind the scenes, I've quickly implemented this method to save time. Let's explore the updates. The code is very simple. First, I get the account data by passing in the account ID. The account data contains a due key and a paid key. Computing the difference yields the balance. If it's a positive number, the method returns true. If it's 0 or less, the method returns false. If the account ID isn't found at all, it returns none. Let's run our test again and ensure it works. This looks great. Now, we've used test-driven development to write code with the added benefit of having good unit tests already in place. Let's test the entire app as a whole in the next few clips.